Hi guys, today we're going to learn about the mathematical properties that we use when we're evaluating expressions. Your topic for today is expressions in math, i.e. math rules, which is so apropos for our page 100 notes. Once again, this goes on page 100 of your interactive notebook. It is titled Expressions in Math, Math Rules, and the essential question is, how can we use the distributive property to evaluate expressions? Please pause the video if you need to write that down, or you can go back. So the first property that we're going to talk about today is the commutative property. The commutative property. And this is changing the orders of factors doesn't affect the product. So every one of these, I'm going to write the definition out, and then once I write the definition out, I'll give you an example, which will help you understand what it means. Okay, so what this means, remember we're talking about order. So if you have like 2 times 3. 2 times 3 equals what, class? 6. Thank you, 6. Well, doesn't also 3 times 2 equal 6? It doesn't matter whether the 3 comes first or the 2 comes first. Either way, it equals 6. That's the commutative property. I like to think of it as like when you commute in a car, like you get from one place to the other, but it doesn't matter if I drive on the 15 or if I drive on another road, I'm still going to get to the same place. It can go in either order. But that's just my own little way of remembering what's the commutative. It's the numbers move around, but the end product stays the same. Now, but here's the interesting thing. Now that we're doing algebraic expressions, it doesn't just mean that we're dealing with numbers. So our variables can also move around, but it's not going to change the process. So, for example, if we were to have A times B, that would be the same as B times A. Now, this doesn't mean that if I do 2A times B, it would be equivalent to 2B times A. The numbers would have to stay with the variable they're connected to. But if I had 2A times B, and then I said it was the same as B times 2A, that would be the same. Do you see how the number that was connected to the variable stayed the same? It stayed connected to its same variable. That's very important. So it also works with addition. So that looks like this. A plus B is the same as B plus A, or if we had 2 plus 3, it would be the same as 3 plus 2. That's the commutative property. Up next, super exciting, is the associative property. The associative property is that changing the grouping of factors doesn't change the product. So let's write that down. Changing the grouping of products, or of factors, excuse me, does not change the product. So once again, we'll give some examples of that. So this is about grouping. So I'm going to underline that word because that's an important word. So what this looks like in terms of numbers. If I were to have 3 times 2 in parentheses and times it by 1, that would be 3 times 2, which is what? Thank you. Times 1, which is 6. Thank you, guys. So the answer would be 6. Well, that would be the same as if I were to do 3 times the parentheses 2 times 1. Let's see if it works. What's 2 times 1?
2.
Thank you, Miguel. What's 2 times 3? 6. Is it the same? Yeah, so it didn't matter where I put the parentheses. As long as it's multiplication, we're good. Okay? So let's look at this in terms of algebra. This would be like if I were to have A times B in parentheses times C would be equivalent to A pulled out of the parentheses times B times C. So it doesn't matter where I put the parentheses. In the end, if it's all multiplication, it's not going to make a difference. It will stay the same. And that's the associative property. Which brings us to the final property that we're going to discuss, and it's the one that we discussed in our last set of notes. It's going to be kind of a review. And that is the distributive property. So the distributive property, and this is the distributive property, I need to add this, of multiplication. So what the rule for this is to multiply a sum or difference by a number, multiply each number in the sum or difference by the number outside the parentheses, then evaluate. That's a lot of words. It sounds more confusing than it is, but let's write the rule down first and then we'll show the practice, okay? Here we go. To multiply a sum. Class, what am I talking about when I say sum? What? Thank you. What am I talking about? Difference. Subtraction. Thank you. Good. So we're talking about addition or subtraction. To multiply a sum or difference by a number. And I'll think about that too. When I say multiplying a sum or difference, I'm talking about an expression or a part of an expression that is inside of parentheses. So I've either added or subtracted within parentheses, and now I'm going to multiply what was in that parentheses times another number or variable. So to multiply a sum or difference by a number, you would multiply each number in the sum or difference by the number outside. Move this up a little bit. Outside the parentheses, and then evaluate. So what this looks like, guys, is if we were to have, I'm going to write it first in terms of algebra, and then I'll do it in numbers. So if we had A outside of parentheses, we're going to multiply A times B minus C. So I have a difference of B minus C, and I'm going to multiply that by A. Okay? This would be the equivalent to A times B. So A times B subtracting A times C. So I go in here, and I multiply it times this, then I subtract, and then it by this times this. And that would be our answer. Now, occasionally I've heard people call this the rainbow method because you're kind of making a rainbow. I did it underneath, so I made it like a happy face. But I've seen people call it the rainbow method. You go out to in, out to in, out to in, and you make sure that you keep whether it's a sum or a difference. But the truth is you're just making sure that you're multiplying each term or each part of the term inside the parentheses by the number directly outside. So let's see this as an actual example. So here's your first example. If we had 6 times 3 plus 2. Now, I could do this traditional order of operations way and just go 3 plus 2 is what? What is it, class? What's 3 plus 2? 5. And then multiply it times the outside of parentheses. 5 times 6 is what? 30. So I could solve it. This is an easy problem, and I'm telling you, we are learning this because it's not always going to be this easy. Sometimes we're going to have variables in here, and we're going to be doing more difficult things. But you have to learn it with the easy way first so that you can build up to the hard way, okay? So let's just do this, and I'll show you how to apply the distributive property to it. So you would start here, and you would go, okay, I'm going to take in or outside the parentheses, and I'm going to multiply it by the first part of the term inside. Okay, so what's the first term inside the parentheses? 3, right? So 6 times 3. What is my operation I'm using? Addition. Write my addition. And then I would go to the next one. 6 times what? 2. All right, so now that I have that, what is 6 times 3? Plus, what is 6 times 2?
12.
Okay, what is 18 plus 12? 30. Did I get my same answer? Yes, because it works. But like I said, sometimes this would be more complicated, and we're going to have to kind of work on it. I'm going to give you an example that is a little bit more complicated. This one, is we're going to use a variable. I'm going to give you x times the difference of 6 minus 2. Okay, this is a little bit more complicated, right? Because if I do 6 minus 2, I'm going to get 4. 4 times x would be 4x. Okay, but with dealing with x's, sometimes our mind gets a little like, woo, what do I do there? So let's try using the distributive property. First of all, we go outside the parentheses. What is the number, or what is the outside the I just gave you the answer. What is outside the parentheses, class? The variable, and what is that variable? X, okay? So we're going to start with x. We're going to multiply it into the parentheses. So x times the first number, which would be what? 6. So x times 6, and then what is your operation inside the parentheses? Minus. Go back to the variable on the outside the parentheses, and times it by inside the parentheses, which is what? 2. All right, now, what is x times 6? Well, that would be 6x. Minus, what's x times 2? 2x. Okay? What is 6x minus 2x? 4x. Good. There's your answer. Now, another thing that you can do with this, guys, is, and I'm going to cram this in here because I want to show you, is sometimes we can have an expression that's long. So, for example, if I could have 15x plus 5, okay? And it'll say simplify this using, or show an equivalent expression using the distributive property. And you're like, well, there's no parentheses there, so I don't know what I'm supposed to do. Well, you're going to put the parentheses in. So what you have to do first is you have to figure out, is there a common factor between 15x and 5? Is there a number that I can divide both of those by evenly? What is it? 5, right? 15x divided by 5 would be 3x. 5 divided by 5 is 1, right? So what I'm going to do is I'm going to then put my parentheses, I'm going to put my 5, so I'm going to find my GCF, and I'm going to put it outside the parentheses. Okay? So I'm really squishing it in here. I'm sorry, guys. So I'm going to put my 5 outside here. Then I'm going to put my parentheses. So see, I'm putting my parentheses. Now what I'm going to do is I'm going to say, okay, my GCF 5 goes into 15x how many times? We already said it. What was it, guys? 3x, right? Can't forget your little x. So now I'm going to write 3x because 5 times 3x is going to be 15x. What is my operation up here? Addition. Keep addition the same. Okay, now how many times does 5 go into your next factor? 1. This is equivalent to this. Let's see if we were to rainbow it out, or if we were to expand it out, would we get it? So 5 times 3x would be 15x, plus 5 times 1 would be 5. Would it be equivalent? Yeah. So that's what we call, I like to call that the reverse distributive property, because instead of distributing the factors out, you're now like finding the GCF and you're making it a little bit more compact. And either will happen. So that kind of concludes the notes part of it. We're going to do a practice. Your face is hilarious. We're going to do some practice, and hopefully it'll make more sense. Okay, guys? So we're going to go to page 99 and go over some of your examples. We good, guys? Okay. All right. So over here on 99, it says, use the distributive property to write an equivalent expression. So remember, we go outside to the inside, keep your operation the same. Okay? So on this one, what is on the outside of the parentheses? 2. That's your factor. You're going to multiply that inside the parentheses. What's the first factor within the parentheses? 6x. What's your operation? What is that operation inside the parentheses? Addition. Keep it the same. We go back outside the parentheses to our factor, which is 2. Multiply it times the second factor inside the parentheses, which is what, class? 7. Okay, now let's evaluate. What's 2 times 6x? 12x. 12x. Good. Remember, it's not just 12, it's 12x. Operation, keep it there. What's 2 times 7? 14. I cannot add 2x to 14. Or, sorry, 12x to 14. 12x is now connected. You can't separate the 12 from the x at this point. So you're going to leave them connected as one term. Okay? And you have to combine all your terms. So you have all your x's together and you have all your numbers without x's together. Okay? We are done. Some of us want to fix that because it bothers us that we don't have one number. We will get, when we do equations, to where we have one number. At this point, we're just getting down to a simplified expression. Okay? Let's do another one. Who wants to help me with this one? Ooh, some brave souls. Haley, go ahead. 4 times 3. Good. She went outside the parentheses to inside. Okay, what next? 4 times 10x. She's kept the operation the same. She went outside and then inside. Okay, what did you evaluate 4 times 12 or 4 times 3? I give the answers all the time. Plus what? 40x. Good. Can we keep going or are we done? We're done. All right, guys. At this point, I want you guys to finish the last 4 problems on your own. Actually, wait. I'm going to be nice to you. Let's go all the way down to number 4. Because I think number 4 is going to be like, oh, when you see it. Because it's different, right? How is it different?
It has 2 variables.
It has 2 variables and how many terms within the parentheses? 3, right? You're like, dude, that's crazy. Let's try it. Okay, first one. Outside the parentheses is what, guys? 9 times what's in the first inside?
3x.
3x. What's our operation?
Addition.
Good. Go back to the 9. 9 times what?
7y.
7y. What's the operation?
Addition.
Addition. Okay. Go back out. 9 times what?
4.
So it's the same thing. I went here to here, plus here to here, plus here to here. Okay? It's the same exact thing. Now let's simplify. What's 9 times 3x? Good. Plus, what's 9 times 7y? 63.
Y.
Plus, 9 times 4?
36.
36. Good, Chaz. All right, that is your answer. Because you can't connect the x to the y to the whole number. They're 3 different terms. You have to keep them separate. Okay? The only other one I thought I would show you is if you see up here on, actually, look at this one. See how it says 7x and the 5 is on the other side? It doesn't matter which side of the parentheses it's on. You can do the same thing. Okay? Got it, guys? All right, finish those problems up on your own. Go back and watch the video again. If you need to, make sure you email me or talk to me if you have any questions. Thanks so much, and have a great day.